Now, in this lecture, we will find out the area of the green shape in three different methods. In the drawing, we have rectangle ABCD. AE is equal to ED. EB is equal to 7 units. BF equals to 9 units, angle ABE is equal to theta, and angle EBF also equals to theta, and we want to find out the area of this green shape. So we'll start with the first method. In the first method, we will extend BE and PF, line segment will extend BE and CD until they intersect with each other. Okay. We define the intersection point as point P, and actually we know that CD or DC is one side of rectangle ABCD, therefore it is absolutely a straight line, and we extended the straight line DC by a straight line, therefore line segment CP will be still a straight line. So I'll write it down. So line segment CP is a straight line. And we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So I read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if we focus on this side of the straight line CP, then we know that the sum of the angles at point D on this side of the straight line CP is equal to 180 degrees according to rule number 1. But before that, we know that all the angles inside the rectangle are right angles. That is to say, this angle is a right angle, it equals to 90 degrees. This angle, it is also a right angle, it equals to 90 degrees. And this angle, it is also a right angle, it equals to 90 degrees. So we know that the sum of the angles on this side of the straight line CP at point D must be equal to 180 degrees according to rule number 1. So that is to say, angle PDE that we will define as angle X plus this angle that equals to 90 degrees must be equal to 180 degrees. So I will write it down. Angle X plus the angle that equals to 90 degrees must be equal to 180 degrees according to rule number 1. So we will subtract 90 degrees from this equality and we will get that X equals to 180 degrees minus 90 degrees it is 90 degrees. So we found out that angle X is a right angle, that is to say it equals to 90 degrees. So we can substitute this angle, angle X, by a right angle. So we actually know that angle PDE is equal to 90 degrees. It is a right angle. And we know that AB is parallel to DC. AB and DC are parallel to each other according to the rule that the opposite sides of a rectangle are parallel to each other. But if AB is parallel to CD, AB will be also parallel to CP because CP, it is the extended CD. Okay, CP and CD lie on the same straight line. So if AB is parallel to the straight line CD, then AB will be also parallel to CP that lies on the same straight line. Okay, so AB is parallel to CP. You can write down that AB is parallel to CP. So CP and CD lie on the same straight line. And if AB is parallel to CD, AB will be also parallel to CP. So you can write down that AB is parallel to CP. And we also have rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. I'll read again rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. So here we know that AB is parallel to CP, and those two angles are defined as alternating angles, okay, and they are located between the parallel lines AB and CP, therefore they are equal to each other. So we can write down that angle ABE in the green triangle is equal to angle EPD in this triangle this angle EPD, and we actually know it is given us in the question that this angle ABE equals to theta, so we can write down that angle AB equals to theta. Again, angle ABE equals to angle EPD according to rule number 2, and we know that angle ABE equals to theta because it is given us in the question. So from this equation, from this equality, we will conclude that angle EPD also equal to theta, so here angle EPD, this angle equals to theta. In the next step, we will prove that those two right triangles can go into each other. So we'll prove that triangle, the right green triangle, triangle ABE, can go to the green to the right triangle, triangle EPD, this triangle. Why they can go into each other? Because first of all, we just right now proved that those two angles, they are equal to each other, they are both equal to theta, so we can write down that angle ABE, this angle, is equal to this angle, angle EPD, and they are both equal to theta. Okay, so angle ABE equals to angle EPD, and they are both equal to theta, and those two angles are right angles, therefore they are equal to each other. So this angle, angle BAE, is equal to this angle, angle PDE, and they are both equal to 90 degrees, they are right angles. So angle BAE equals to angle PDE equals to 90 degrees, and we also know that those two angles, they are equal to each other because they are vertex angles, and we have the rule that vertex angles are equal to each other. So angle AEB is equal to angle PED, this angle, according to the rule that vertex angles are equal to each other. I'll repeat again. Angle AEB equals to angle PED, according to the rule that vertex angles are equal to each other. And we also know that AE equals to ED. It is given us the question that AE equals to ED. So AE equals to ED, according to what is given us in the question. Okay, AE equals to ED. It is given us the question. So actually we proved that those two right triangles can go to each other according to angle side angle rule. So I write it down. We proved the triangle ABE is congruent. This is the sign of congruent to triangle EPD according to angle rule. Okay, I'll repeat again. Triangle ABE is congruent to triangle EPD according to angle rule. So what is angle? According to side rule. According to angle side angle rule. According to angle side angle rule. I'll repeat again. Triangle ABE is congruent to triangle EPD according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle, then the triangles can go into each other according to angle, side angle rule. So I'll repeat again on angle, side angle rule. According to angle, side angle rule, if two angles and the side that included between those two angles in one triangle can go and correspondingly to two angles and the side that included in another triangle, then the triangles can go into each other according to angle, side angle rule. And we actually proved that those two angles and the side that included between those two angles, that is to say side AE, in the green triangle, triangle AEB, can point to those two angles and the side that included between those two angles, that is to say ED, this side, in triangle EPD. Therefore we proved that those two triangles can go into each other according to angle, side angle rule. Okay? And from the fact that those two triangles can go into each other, we will conclude that BE equals to EP. BE equals to EP. I'll repeat again, BE equals to EP according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say BE and EP, will be equal to each other, that is to say BE equals to EP. But we know that BE equals to 7 units. It is given us in the question, so we can write here that BE equals to 7 units. And from this equation, from this equality, we will conclude that EP also equals to 7 units. EP also equals to 7 units. So we can write here that EP equals to 7 units. So in the next step we will define the area of quadrilateral EBFD SY. Okay, the area of quadrilateral EBFD will be defined as Y. That is to say, the area of triangle EBFD equals to Y according to our definition. Okay, the area of quadrilateral EBFD equals to Y, and we will define the area. So the area of quadrilateral EBFD is Y according to our definition, and the area of the right triangle ABE will be defined as X. So the area of the green shape, the area of this green shape will be equal to X plus Y. Write it down. The area of the green shape this is the sign of area. It means the area of the green shape. The brackets is the sign for the area. So the area of the green shape equals to X plus Y. And because of the fact that those two right triangles can go into each other, they will have also the same areas. So if the area of triangle ABE, the green right triangle ABE is X, then the area of triangle EPD will be also equal to X, because they can go into each other. Therefore they have also the same areas. And what is the area of triangle PBF? The area of triangle PBF also equals to X plus Y. So we can write down the area of triangle PBF also equals to X plus Y. So the area of triangle PBF is equal to the area of the green shape. They both are equal to X plus Y square units. Therefore, we can find out the area of triangle PBF, and in this way we will find out also the area of the green shape. Okay? And we also know that triangle PBF is an isosceles triangle. Why? Because it has two equal angles. Those two angles are both equal to theta. So we can write down that triangle PBF is an isosceles triangle. I'll repeat again. Triangle PBF is an isosceles triangle because it has two angles that are equal to each other. They are both equal to theta. Those two angles. And we also have rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So I'll read rule number 3 again. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle ABC, so if triangle ABC is an isosceles triangle, so this is triangle ABC, and it is an isosceles triangle because those two angles, they are equal to each other, they are both equal to theta, and the base of the isosceles triangle ABC is BC. So if from the vertex A we will draw median to the base, here we define the touching point between the median to the base BC as point O. So this is the median to the base of the isosceles triangle ABC, and the median according to its definition is bisects the base BC into two equal parts, that is to say BO equals to OC. So if BO equals to X, then OC will be also equal to X. Okay, and according to rule number 3, the median to the base, that is to say AO, in an isosceles triangle ABC, is not only bisects the base BC into two equal parts, but it is also perpendicular to the base, that is to say this angle is equal to 90 degrees, and this angle is also equal to 90 degrees. Okay, so I'll repeat again on rule number 3. The median to the base in an isosceles triangle, that is to say AO is the median to the base in the isosceles triangle ABC. The median to the base is perpendicular to the base. So in the isosceles triangle ABC, the median AO is perpendicular to the base BC, that is to say this angle equals to 90 degrees, and this angle is also equal to 90 degrees. Okay, actually this is the meaning of rule number 3, and we can implement rule number 3 in our drawing, because in our drawing we have the median, we have an isosceles triangle PBF is an isosceles triangle because it has two angles that are equal to each other, and the base is PB. So the median to the base, it will be FE. So YFE is the median to the base, because FE bisects the base into two equal parts. As you can see, EB is equal to 7 units, and EP is also equal to 7 units, so it bisects the base PB into two equal parts. But according to rule number 3, it is not only bisects the base, but it is also perpendicular to the base PB. That is to say, this angle is equal to 90 degrees. It is a right angle, and this angle also equals to 90 degrees. Okay? So this angle is equal to 90 degrees. And because of the fact that this angle is a right angle, it equals to 90 degrees, then triangle EBF is a right triangle. Okay? Triangle EBF is a right triangle. Again, the median EF is perpendicular to the base PB, so angle PEB, this angle is a right angle, and therefore triangle EBF is a right triangle, so we can write down the triangle EBF is a right triangle, and in the right triangle, triangle EBF, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this green right triangle, triangle EBF, it is actually FB because it is in front of the right angle. So the square of the hypotenuse is BF squared. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to BE squared plus EF squared. I will repeat again. In the right triangle, triangle EFB, according to the Pythagoras theorem, BF square equals to EB square equals to BE square plus EF square. But we know it is given us in the question that BF equals to 9 units. BF equals to 9 units, so BF square is 9 square. 9 square is 81. And it equals to BE square. BE equals to 7 units. You can see here BE equals to 7 units. units. It's given us in the question. So B square will be equal to 7 square. 7 square is 49 plus EF square. So in conclusion, we got that according to equation number 1, 81 equals to 49 plus EF square. We will subtract from this equation number 1, 49. 81 minus 49 is 32, so I write it down. 32 equals to EF square. We take a root from this equation number 1, and we will get that EF equals to the square root of 32. 32 is 16 times 2, so I write it down. 16 times 2, and the square root of 16 is 4, so I write it down. In conclusion, we will get that EF equals to 4 times square root of 2 units. EF equals to 4 times square root of 2 units, so we can write here that EF equals to 4 times square root of 2 units. Now it is very easy to find out the area of triangle PBF, because we know that the base PB equals to 7 plus 7, that is to say to 14, and the height to the base is equal to 4 times square root of 2 units, and the area of any triangle is equal to the base times the height to the base over 2. So the area of triangle PBF is equal to the base of the triangle times the height to the base over 2. I will repeat again. The area of triangle PBF, that is also the area of any triangle, is equal to the base times the height to the base over 2. And the base of triangle PBF, the base is PB. PB is the base. Times the height to the base. The height to the base is EF over 2. Again, the area of triangle PBF, that is also the area of the green shape, is equal to PB times EF over 2. PB is equal to 7 plus 7, that is to say it equals to 14 units. EF is equal to 4 times square root of 2 units over 2. So in conclusion, we found out that the area of the isosceles triangle PBE is equal to 14 times 4 times 2 over 2. 14 over 2 is 7, so I write it down. We found out that the area of the isosceles triangle triangle PBE is equal to 7 times 4 times square root of 2. Okay, so the area of the isosceles triangle PBE, that is also the area of the green shape, equals to 7 times 4 times square root of 2. 7 times 4 is 28, so I write it down. So in conclusion, we found out that the area of the isosceles triangle PBE, that is also the area of the green shape that we are looking for, is equal to 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. So I repeat again. The area of the isosceles triangle PBE equals to the area of the green shape, and the area of the green shape equals to 28, either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the first method. In the next step, I will explain to you how to find out the area of this green shape according to the second method. We know that the opposite sides of a rectangle are parallel to each other. ABCD is a rectangle, so AB is parallel to CD, and if AB is parallel to CD, AB will be also parallel to part of CD. That is to say, AB will be also parallel to CF. So AB is parallel to CF. And according to rule number 2, those two angles that are located between the parallel lines CF and AB will be equal to each other. I mentioned rule number 2 in method 1. Those are alternating angles. Those two alternating angles are located between the parallel lines CF and AB, therefore they are equal to each other. But this angle is theta plus theta is 2 theta. So this angle that equals to it will be also equal to 2 theta. So this angle equals to 2 theta according to rule number 2, that alternating angles between parallel lines are equal to each other. And we also know that all the angles inside a rectangle, they are right angles. Therefore, this angle is a right angle. And this angle, it is also a right angle. And this is also a right angle. So we will focus on this right triangle, triangle ABE. First of all, we will define AE as X. According to what is given us in the question, AE equals to ED. AE equals to ED, but if AE equals to X, then ED will be also equal to X, because they are equal to each other. So I will draw again the right grand triangle, triangle ABE, and we will analyze this right triangle. So this is the right triangle, triangle ABE. You can see that sinus theta equals to x over 7. Sinus theta equals to x over 7. So this is the right triangle, triangle AEB. And in the right triangle, triangle BFC, this lower right triangle, triangle BFC, you can see from the drawing that first of all, what is the side of BC? We know that the opposite sides of a rectangle are equal to each other. That is to say AD equals to BC. But AD equals to x plus x. That is to say AD equals to 2x. Therefore BC will be also equal to 2x because AD equals to BC. So what is the value of sinus 2 theta? Sinus 2 theta equals to 2x over the hypotenuse, that is 9. Again, sinus 2 theta equals to 2x over 9. And according to the trigonometric identity, that sinus 2 theta equals to 2 sinus theta cosine theta, so I write it down. The trigonometric identity that states that sinus 2 theta equals to 2 sinus theta cosine theta. So we actually can substitute sinus theta in equation number 2 by 2 sin theta cosine theta. So we'll do it and we'll get that according to equation number 2, 2 sin theta cosine theta equals to 2x over 9 but according to equation number 1, that sin theta equals to x over 7, if we put the value of sin theta from equation number 1 inside sin theta in equation number 2, we will get that 2 sin theta is x over 7 according to equation number 1 times cosine theta it equals to 2x over 9 according to equation number 2. So here we have 2x in both sides of equation number 2, so 2x will get cancelled. And what is left after we cancel 2x from equation number 2? What is left? It is actually here cosine theta over 7 equals to 1 over 9. We will multiply equation number 2 by 7 and we will get that cosine theta equals to 7 over 9. So we found out that cosine theta equals to 7 over 9. So I'll write it in a new page. Cosine theta equals to 7 over 9. So if we draw the right triangle for this equality, we will get that we will have a right triangle with one angle that equals to theta. This angle is a right angle. The hypotenuse is equal to 9 units, and the angle, the side that is near angle theta will be equal to 7 units according to this equality. And the side that is in front of angle theta is the missing side, so we'll define it as S. We will find out the value of S according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say S square plus 7 square equals to 9 square. So S square plus 7 square is 49 equals to 81. We will subtract 49 from this equation and we will get that S square equals to 81 minus 49 is 32. Here we will take a root out. We will take a root after from this equation, and we will get that S equals to the square root of 32, and 32 is 16 times 2. And the square root of 16 is 4, so I'll write it down. So in conclusion, we found out that S equals to 4 times square root of 2 units. So we can write here that S equals to 4 times square root of 2 units. So now we can calculate the value of sine theta. From this drawing, we can see that sine theta equals to 4 times square root of 2 over 9. So in conclusion, we found out that sine theta equals to 4 times square root of 2 over 9, and cosine theta equals to 7 over 9. Okay, sine theta equals to 4 times square root over 9 and cosine theta equals to 7 over 9. According to equation number 1, here sine theta equals to x over 7. So here we write it down. Sine theta equals to x over 7. Here we multiply equation number 1. First of all, we know that sine theta is equal to 4 times square root of 2 over 9, so we'll substitute sine theta in equation number 1 by 4 times square root of 2 over 9. 4 times square root of 2 over 9 equals to x over 7, according to equation number 1. We will multiply this equation number 1 by 7, and we will get that x equals to 28 times square root of 2 over 9. So we found out that x equals to 28 times square root of 2 over 9. Here we can also write down that x equals to 28 times square root of 2 over 9. So AD is equal to x plus x. Yes, so AD will be equal to 2x will be equal to 56 times square root of 2 over 9. Here also 2x will be equal to 56 times square root of 2 over 9. In the next step, we'll calculate the value of cosine theta when we focus on the right triangle, triangle ABE. You can see here that cosine theta, if you focus on the right triangle, triangle AEB, cosine theta equals to AB over 7 okay, in the right triangle, triangle AEB, we can see that cosine theta equals to AB over 7, but we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta in this equation by 7 over 9, and we will get that 7 over 9 equals to AB over 7. We will multiply this equation by 7, and we will get that AB equals to 7 times 7 is 49 over 9. So we found out that AB equals to 49 over 9. Here AB equals to 49 over 9. And we know that the opposite sides of a rectangle are equal to each other. That is to say AB equals to DC. But DC equals to 49 over 9. So AB equals to 49 over 9. So DC will be also equal to 49 over 9. So we can write here that DC equals to 49 over 9, and here we will focus on the lower right triangle, triangle BFC. In this right triangle, triangle BFC, so in the right triangle, triangle BFC, cosine 2 theta equals to FC over 9. Cosine 2 theta equals to FC over 9. Okay, cosine in the right triangle, triangle BFC, cosine 2 theta equals to FC over 9. We will multiply this equation by 9 and we will get that FC equals to 9 times cosine 2 theta but according to the trigonometric identity, cosine 2 theta is equal to 2 cosine square theta minus 1. So we can substitute cosine 2 theta in this equation by 2 cosine theta minus 1. So we'll do it now and we will get that FC equals to 9 times, and cosine 2 theta according to this trigonometric identity is equal to 2 cosine square theta minus 1. But we have already found out that cosine theta equals to 7 over 9. So we can substitute cosine theta by 7 over 9 in this equation. We will get that FC equals to 9 times 2 cosine theta equals to 7 over 9. Therefore, cosine square theta will be equal to 7 over 9 squared minus 1. Okay, so here FC equals to 9 times 2, 7 square is 49, over 8 square is 81, and minus 1 is minus 81 over 81. In conclusion, we got that FC equals to 9 times 2 times 49 is 98 minus 81 over 81. So FC equals to 9 times 98 minus 81 is 17. So here we got that FC equals to 9 times 17 over 9. We will divide the numerator and the denominator by 9, and we will get that FC equals to 9 over 9 is 1, so in the numerator we left only with 17, and in the denominator 81 over 9 is 9. So in conclusion, we got that FC equals to 17 over 9. FC equals to 17 over 9, and what is the value of df? Here FC equals to 17 over 9. Okay, and what is the value of df? df equals to dc minus fc. df equals to dc minus fc. df equals to dc minus fc. So df equals to dc. dc is 49 over 9 minus fc. fc is 17 over 9. So actually we found out that DF equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32. So I write it down. In conclusion, we found out that DF equals to 32 over 9. So I write it down. DF equals to 32 over 9. So we have all the values of the sides of trapeze ABDF, so we can easily find out the area of trapeze ABDF, that is also the area of the green shape that we are looking for. We'll find out that the area of trapeze ABDF is equal to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. I will repeat again, the area of the green trapeze ABDF, that is also the area of the green shape, it is equal to the sum of its sides, that is to say it equals to AB plus DF times the height, that is AD, the height of the trapeze ABDF is AD, over 2. So the area of trapeze ABDF is equal to AB is 49 over 9. AB is 49 over 9 plus DF equals to 32 over 9 times the height AD. AD equals to 56 times square root of 2 over 9 all divided by 2. So the area of trapeze ABDF, that is also the area of the green shape, equals to this expression. It is 49 over 9 plus 32 over 9. 49 plus 32 is 81, so we have 81 over 9. So I write it down. It equals to 81 over 9 times 56 times square root of 2 over 2, all divided by 2. So here we have, it is 56 times square root of 2 over 9, all divided by 2. Here 9 times 9 is 81. And 81 over 81 is 1, so this expression will get cancelled. And 56 over 2 is 28. So we found out that the area of trapeze ABDF, that is the area of the green shape, the area of the green shape that we are looking for, is equal either to 56 over 2 is 28, so we have 28 times square root of 2 square units. So the area of the green shape is equal either to 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. I'll repeat again. The area of the green shape is equal to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method. In the next step, I will present to you how to find out the area of this green shape according to the third method. So in the third method, we will draw perpendicular from point E to BF. We will draw perpendicular from point E to side BF. So this angle is a right angle, it equals to 90 degrees. And this angle, it is also a right angle, it equals to 90 degrees. And we also know that all the angles inside a rectangle are right angles, therefore this angle, it is a right angle, that is to say it equals to 90 degrees. This angle, it is also a right angle, it equals to 90 degrees. And this angle, it is also a right angle, that is to say it equals to 90 degrees. Okay? So, in the next step, we will prove that those two right green triangles can congruent to each other. Okay? So, actually, we will prove that the right triangle, triangle AEB, the right green triangle, triangle AEB, is congruent to the green right triangle, triangle EBM. Actually, we will define the touching point between the perpendicular from point E to BF as point M. The touching point between the perpendicular from point E to BF is defined as point M. So this right triangle is triangle EBM. So we actually will prove that the right triangle, triangle ABE, is congruent to the right triangle, triangle EBM. Okay? So, first of all, we know that those two angles, they are equal to each other, they are both equal to theta according to what is given us in the question. So we can write down that angle ABE, or triangle ABE, is equal to angle EBM, this angle, and both angles are equal to theta according to what is given us in the question. I'll repeat again. Angle ABE equals to angle EBM equals to theta according to what is given us in the question. And we also know that those two angles, they are equal to each other, they are both right angles. So angle BAE, this angle, is equal to this angle, angle EMB. And they are both equal to 90 degrees according to what is given us in the question. So angle BAE is equal to angle EMB, and they are both equal to 90 degrees. They are both equal to 90 degrees. It is not given us, but we draw this angle. So this is from point T we draw perpendicular to M. So this angle is right angle, because we did it like this. It is a construction, and this angle, it is actually one angle out of four angles of a rectangle, and we know that all angles of a rectangle are right angles, therefore it is a right angle. And we also know that those two angles, they are equal to each other according to third angle theorem. So we can write down that angle AEB is equal to angle BEM according to third angle theorem. I'll repeat again. Angle AEB equals to angle EBM according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then those two triangles, then the third pair of angles must also congruent. I'll repeat again. If two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we actually proved that those two angles in the right triangle, triangle ABE, congruent to those two angles in the right triangle, triangle BME. Therefore, we actually proved that those two triangles have two pairs of angles that congruent to each other. Therefore, the third pair of angles must also congruent. That is to say, this is the third pair of angles, and they must also equal to each other. That is to say, angle MEB must be equal to angle AEB. Okay? Angle AEB must be equal to angle BEM according to third angle theorem. Okay? And we have a common side. EB is equal to EB. It's a common side that belongs to both triangles. I'll repeat again. EB equals to EB is a common side that belongs to both triangles. So we actually proved that those two triangles, those two right triangles, can go into each other according to angle side angle rule. Okay, so we proved the triangle AEB triangle AEB is congruent to triangle EBM according to angle side angle rule. And from the fact that those two triangles congruent to each other, from the fact that those two triangles congruent to each other, we will conclude that AB is equal to BM. AB is equal to BM and AB is equal to BM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AB and BM will be equal to each other. And if we define AB as Y, then BM will be also equal to Y because they are equal to each other. Okay, so AB is equal to BM equal to Y, and we can also conclude from the fact that those two triangles congruent to each other that AE is equal to EM. AE equals to EM according to the same rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AE and EM will be equal to each other. And if we define AE as X, then EM will be also equal to X because they are equal to each other. Okay, so AE equals to EM equals to X. According to our definition, it equals to X. But we also know that AE equals to EM. It is given us in the question that AE equals to ED. Here, AE equals to ED. It is given us in the question. So, if AE equals to X, then ED will be also equal to X. And we also know that BF equals to 9 units. BF equals to 9 units. It is given us in the question. So if BF equals to 9 units and BM equals to Y, then MF equals to BF minus BM. That is to say, MF equals to BF, that is 9 units, minus BM, that is Y. So in conclusion, we found out that MF equals to 9 minus Y. In the next step, we will join together points E and F by a straight line. And we will prove that those two right triangles can go into each other. Okay? So we will prove that the right green triangle EDF, this right green triangle, is congruent to the right green triangle EMF, this right green triangle. First of all, in last slide, now prove that EM is equal to ED and that equals to X according to our definition. So EM equals to ED equals to X. I repeat again. EM equals to ED equals to X. According to our definition, it equals to X. And we also know that those two angles, they are equal to each other, they are both right angles, so angle EMF is equal to this angle EDF, and they are both equal to 90 degrees, they are right angles. So angle EMF equals to angle EDF, and they are both right angles, they are equal to 90 degrees. And we also have a common side. EF is a common side, it belongs to both triangles, so EF equals to EF is a common side that belongs to both triangles. I'll repeat again. EF equals to EF is a common side that belongs to both triangles. So by proving those three things, we actually proved that those two right triangles EDF and EMF congruent to each other according to rule number 5. So what is rule number 5? I'll write it down. Rule number 5 states that if the hypotenuse and a perpendicular in two right triangles congruent, then the triangles congruent to each other. So I write rule number 5 again. According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And we actually proved that the hypotenuse EF and the perpendicular EM in the right green triangle EMF congruent to the hypotenuse EF and the perpendicular ED in the right triangle EDF. Therefore, we proved that those two right green triangles congruent to each other according to rule number 5. Okay, so triangle EDF is congruent to triangle EMF according to rule number 5. Okay, and from the fact that those two right triangles congruent to each other, we will conclude that MF is equal to DF. MF is equal to DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides DF and MF will be equal to each other. That is to say, DF equals to MF, or MF equals to DF. But we know that MF equals to 9 minus Y. We have already found out that MF equals to 9 minus Y. So from this equation, from this equality, we will conclude that DF also equals to 9 minus Y. DF also equals to 9 minus Y. df also equals to 9 minus y. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to DC. AB equals to DC. But we know that AB equals to y. Therefore, DC will be also equal to y. Okay? DC will be also equal to y. So DC equals to y. DC equals to y. DC equals to y and df equals to 9 minus y. So FC equals to DC minus df. FC equals to DC minus df. You can see it clearly from the drawing that FC equals to DC minus df. So FC equals to DC is y minus df. df is 9 minus y. So FC equals to y minus 9 minus y. We'll open the brackets on this equation and we'll get that FC equals to y minus 9 minus y is plus y. So in conclusion, FC equals to y plus y is 2y minus 9. In conclusion, we found out that FC equals to 2y minus 9. FC equals to 2y minus 9. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AD equals to BC. But AD equals to x plus x. That is to say, AD equals to 2x. Therefore, BC will be also equal to 2x. Okay? And if we focus on the right green triangle, triangle ABE, from the right green triangle, triangle ABE, we can see that according to the Pythagoras theorem, x squared plus y squared equals to 7 squared. X squared plus y squared equals to 7 squared, that is 49. I repeat again, in the right triangle, triangle ABE, according to the Pythagoras theorem, x squared plus y squared equals to 49. And then when we focus on the right triangle, triangle BFC, this lower right triangle BFC, on the right triangle, triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is equal, is BF, it is equal to 9 units. So the square of the hypotenuse is 9 square. 9 square is 81. So 81 equals to the sum of the squares of the perpendiculars. And that is to say, it is FC squared plus BC squared. I repeat again, in the right triangle, triangle BFC, according to the Pythagoras theorem, 81 equals to FC squared plus BC squared. So 81 equals to FC squared. FC is 2y minus 9. So FC squared will be equal to 2y minus 9 squared plus BC squared. BC is 2x, so BC squared will be equal to 2x squared. So in conclusion, we found out that 81 equals to 2y minus 9 squared plus 2x squared. We will open the brackets on this side of equation number 2, and we will get that 81 is equal to 2y minus 9 squared. It is 4y squared plus 81 plus minus 36y plus 2x squared is 4x squared. So here we have 81 on both sides of equation number 2, so 81 will get cancelled. We'll get that according to equation number 2, 0 equals to 4. We will take a common factor of 4 from 4x squared and 4y squared. Inside the brackets we will have x squared plus y squared minus 36y. We will add to this equation number 2, 36y, and we will get that 36y equals to 4 times x squared plus y squared. But according to equation number 1, this equation x squared plus y squared equals to 49. So we can substitute x squared plus y squared in this equation number 1 by 49. We will do it now, and we will get that 36y equals to 4 times and x squared plus y squared equals to 49 according to equation number 1. So here we will divide this equation number 2 by 4, and we will get that 9y equals to 49. We will divide this equation number 2 by 9, and we will get that y equals to 49 over 9. We found out that according to equation number 2, y equals to 49 over 9. But according to equation number 1, x squared plus y squared equals to 49. So we can substitute y squared. We can substitute y squared in equation number 1 by 49 over 9 squared, because y equals to 49 over 9. So we'll do it now, and we will get that x squared plus y squared is 49 over 9 squared equals to 49. We will subtract 49 over 9 squared from this equation number 1, and we will get that x squared is equal 49 is 7 squared minus 49 over 9 squared So here we will use the algebraic identity that a squared minus b squared equals to a plus b, a minus b. Okay, and in our equation number 1, b squared is 0, b squared is 0, a equals to 7, b equals to 49 over 9. So we get that according to equation number 1, x squared equals to a plus b. A plus b is 7 plus 49 over 9, and a minus b is 7 minus 49 over 9. So here we will multiply 7 by 9, and then we will divide it by 9 in order to have a common factor with this expression, that we will get that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. So we got that x squared is equal to 63 plus 49 is 112, and 63 minus 49 is 14. So in conclusion, we got that x squared equals to 112 over 9 times 14 over 9. 112 is 8 times 14, so I'll write it down. We'll substitute 112 by 8 times 14. X squared is equal to 8 times 14 times 14 over 9 times 9. We know that 8 is 2 times 2 times 2, so we'll substitute 8 by 2 times 2 times 2 in equation number 1, and we will get that according to equation number 1, x squared equals to 2 times 2 times 2 times 14 times 14 over 9 times 9. So we got this expression. Here we will take a root out of this equation, equation number 1, and we will get that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. And the square root of 2 times 2 is 2. The square root of 14 times 14 is 14. And the square root of 9 times 9 is 9, and inside the brackets we left only with 2. So in conclusion, we got that x equals to 2 times 14 times square root of 2 over 9. 2 times 14 is 28. So in conclusion, we found out that x equals to 28 times square root of 2 over 9 units. And we have already found out that y equals to 49 over 9. Now we can easily find out the area of trapeze ABDF, that is also the area of the green shape. We will find out that the area of trapeze ABDF, actually the formula for the area of any trapeze is equal to the sum of its sides. That is to say, in this case it is AB plus DF times the height of the trapeze, that is AD, over 2. And repeat again, the formula for the area of any trapeze is the sum of its base, that is in this case is AB plus DF, plus the height, that is AD, over 2. Okay, and So the area of trapeze ABDF will be equal to AB. AB is Y. AB equals to Y, according to definition, plus DF. We have already found out that DF equals to 9 minus Y times the height AD. AD equals to 2x, x plus x is 2x, so AD equals to 2x over 2. So, in conclusion, we found out that the area of the green shape is equal to y plus 9 minus y times 2x over x. Y minus y is 0, and 2x, 2 over 2 is 1, so we left only with 9x. We found out that the area of the green shape, that is also the area of trapeze ABDF, is equal to 9x. That is to say, it equals to 9 times, and the value of x is 28 times square root of 2 over 9. 9 over 9 is 1, so 9 will get cancelled. We found out in conclusion that the area of the green shape equals to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. I repeat again, we found out, according to method 3, according to the third method, we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green shape, and in the first method, we made a construction. We extended line segment BE and line segment CD until they intersect with each other at point P, and we actually know that CD is one side of rectangle ABCD, therefore it is absolutely a straight line, and we extended the straight line CD by a straight line, so it still will be a straight line. CP is still a straight line, and we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees, and we know that CP is a straight line, or PC is a straight line. So if we focus on this side of the straight line PC, then at point D, the sum of the angles must be equal to 180 degrees according to rule number 1. Which angles we have at point D? We have here angle X plus this angle that is a right angle. The sum of them must be equal to 180 degrees. So according to rule number 1, X plus 90 degrees must be equal to 180 degrees. We subtracted 90 degrees from this equality, and we got that angle X equals to 90 degrees. Angle X equals to 90 degrees. So this angle, it is a right angle. We substituted it by a right angle, as you can see. Then we actually know that AB is parallel to CD according to the rule that the opposite sides of a rectangle are parallel to each other. So if AB is parallel to CD, then AB will be also parallel to CP because CP is one straight line. AB is parallel to the straight line CD, therefore AB will be parallel to the same straight line CP. So we know that AB is parallel to CP, and we have rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. So those two angles, they are located between the parallel lines AB and PC. Therefore, they are equal to each other according to rule number 2. That is to say, angle ABE will be equal to angle EPC. Angle ABE equals to angle EPD. Angle EPD according to rule number 2. But we know that angle ABE equals to theta. Angle EPD equals to theta according to what is given us in the equation. Angle AB equals to theta. From this equality we will conclude that angle APD also equal angle EPD also equals to theta. So this angle EPD also equals to theta. Then we proved that those two right triangles can go into each other. We proved that triangle ABE can go into triangle EPD. Why they can go into each other? Because first of all, we just right now proved that those two angles, they are equal to each other. They are both equal to theta. So angle ABE equals to angle EPD, and they are both equal to theta. And we also know that angle BAE is equal to angle PDE. Those two angles, they are equal to each other. They are both equal to 90 degrees. Angle BAE equals to angle PDE. They are both equal to 90 degrees. And we also know that those two angles, they are equal to each other according to the rule that vertex angles are equal to each other. So angle AEB is equal to angle PED according to the rule that vertex angles are equal to each other. And we also know that AE is equal to ED. AE is equal to ED according to what is given us in the question. So we actually proved that the right triangle ABE can go into the right triangle EPD according to angle side angle rule. What is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles in one triangle can go in correspondingly to two angles in the side that included in another triangle, then the triangles can go into each other according to angle side angle rule. And we actually proved that those two angles in the side that included, that is to say AE, in the green triangle, triangle ABE, can go into those two angles in the side that included, that is to say side ED, in the right triangle, triangle EPD. Therefore, we proved that those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that BE equals to EP. BE equals to EP according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides BE and EP will be equal to each other. That is to say, BE equals to EP. But according to what is given us in the question, BE equals to 7 units. BE equals to 7 units. From this equality, we will conclude that EP also equals to 7 units. Here, EP equals to 7 units. Then we defined the area of quadrilateral, the green quadrilateral BEDF SY. Quadrilateral BEFD equals to Y according to our definition. and we define the area of the green right triangle, triangle ABE, as x. So the green area is the size of the green area, it is actually equal to x plus y. The area of the green, so the green shape, the area of the green shape, it is equal to x plus y, as you can see from the drawing, it equals to x plus y. And but because of the fact that those two triangles can go into each other, they also have the same areas. It means that if the area of triangle ABE, the green right triangle ABE equals to x, then the area of the right triangle, triangle EPD will be also equal to x because of the fact that they can go into each other, therefore they have the same areas. So the area of triangle EPD will be also equal to x, and the area of triangle PBF, as you can see from the drawing, it also equals to x plus y, exactly as the area of the green shape that is also x plus y. So we can calculate the area of triangle PBF, and in this way we will also know the area of the green shape that is exactly as the area of the triangle PBF. Okay, the area of the green shape equals to x plus y, and the area of triangle PBF also equals to x plus y, so we will calculate the area of triangle PBF, and in this way we will find out the area of the green shape. We know that triangle PBF is an isosceles triangle. This triangle is an isosceles triangle. Why? Because it has two angles that are equal to each other, and we also have rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. Okay, so what is the meaning of rule number 3? The meaning of rule number 3 is that if we have triangle ABC that is an isosceles triangle, why it is an isosceles triangle? Because it has two angles that are equal to each other, they are both equal to theta. And the base of triangle ABC is BC. The base of the isosceles triangle, triangle ABC, is BC because here are located the two equal angles. And if from the vertex A we will draw median to the base BC, then the median is defined as something that bisects the angle, bisects the side. So the median AO is bisects BC into two equal parts, that is to say BO equals to OX equals to X. And according to rule number 3, the median AO, it is not only bisects the base BC, but it is also perpendicular to the base BC. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule number 3. So we can implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle, triangle PBF, and in this isosceles triangle we have the median FE. Why it is the median? Because FE bisects the angle BP into two equal, bisects the base BP of the isosceles triangle PBF into two equal parts. That is to say, BE equals to EP equals to 7 units, and the FE, that is the median, according to rule number 3, it is also perpendicular to the base BP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So if this angle is equal to 90 degrees, then triangle BEF is a right triangle. So we can implement the Pythagoras theorem in this right triangle in order to find out the length of EF. Okay, so according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. In the right triangle, triangle BEBF, and the square of the hypotenuse is BF squared, and it is equal to BE squared plus EF squared. BF equals to 9 units, as you can see here. BF equals to 9 units, therefore BF squared is 9 squared. 9 squared is 81. EB equals to 7 units, so EB squared is 7 squared. 7 squared is 49. So we got equation number 1 that states 81 equals to 49 plus EF squared. We subtracted 49 from this equation, equation number 1, and we got that 81 minus 49 is 32. So 32 equals to EF squared. We took a root of this equation, equation number 1, and we found out that EF equals to the square root of 32. 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times 2. Here, EF is equal to 4 times 2. Okay, and we also know that BP is equal to 7 plus 7, so we can easily find out the area of triangle, the isosceles triangle, triangle PBF. The area of any triangle is equal to the base of the triangle times the height to the base over 2. And this is also the area of the isosceles triangle, triangle PBF. The base of the isosceles triangle, triangle PBF is BP. The base is PB, and the height to the base is AEF. Okay, the height to the base is EF, all divided by 2. PB equals to 7 plus 7, that is 7 plus 7, that is to say it equals to 14 units. EF equals to 4 times square root of 2 units, all divided by 2. So we got that the area of the isosceles triangle, triangle PBF equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7. So in conclusion, we found out that the area of triangle PBE, that is also the area of the green shape, is equal to 14 over 2 is 7, so it is 7 times 4 times square root of 2. 7 times 4 is 28, so in conclusion we found out that the area of the green shape is equal to either 28 times square root of 2 units, or in terms of numbers, the area of the green shape is equal to 39.6 square units. So we finished with the first method. Then I explained to you how to find out the area of the green shape according to the second method. In the second method, we actually know that AB is parallel to CD because of the fact that the opposite sides of a rectangle are parallel to each other. If AB is parallel to DC, then AB will be also parallel to the part of DC. That is to say, AB will be also parallel to FC, that is part of DC. So we know that AB is parallel to FC, and according to rule number 2 that I mentioned in method 1, alternating angles between parallel lines are equal to each other. That is to say, those two angles are defined as alternating angles, and they are located between the parallel lines AB and FC, therefore they are equal to each other. So those two angles, they are equal to each other. And this angle is theta plus theta, that is to say this angle equals to 2 theta. So this angle will be also equal to 2 theta. So angle BFC equals to 2 theta. Okay? And we also know that all the angles inside a rectangle are right angles, therefore those 1, 2, 3 angles are right angles. Then we focus on the right green triangle, triangle ABE, and on the right green triangle, triangle ABE, I actually drew again the right green triangle, triangle ABE. In the right green triangle, triangle ABE, we know that we have angle theta, we defined AE as x. We defined AE as x, so ED will be also equal to x because AE equals to ED. So AE equals to x. We know that EB equals to 7 units according to what is given us in the question. And this is a right triangle. This angle is angle theta. So we can see from the drawing that sinus theta equals to x over 7. This is equation number 1. And if we focus on the lower right triangle, triangle BFC, you can see that here, first of all, we know that AD is equal to BC according to the rule that the opposite sides of a rectangle are equal to each other. And AD equals to x plus x, that is to say AD equals to 2x. So BC will be also equal to 2x. Okay? And we know that BF equals to 9 units. This is given us in the question. So in the right triangle, triangle BFC, sinus 2 theta will be equal to 2x over 9. Okay, according to question number 2, in the right triangle BFC, sinus 2 theta equals to 2x over 9. And we have the trigonometric identity that states that sinus 2 theta equals to 2 sine theta cosine theta. So we can substitute sinus 2 theta in equation number 2 by 2 sine theta cosine theta. We did it and we got that 2 sine theta cosine theta according to equation number 2 equals to 2x over 9. But according to equation number 1, sine theta equals to x over 7. So we can substitute sine theta in equation number 2 by x over 7 from equation number 1. We did it and we got that 2 times sine theta is x over 7 times cosine theta equals to 2x over 9. We have 2x in both sides of equation number 2, so 2x will get cancelled. And we got that cosine theta over 7 equals to 1 over 9. We multiplied this equation number 2 by 9 and we got that cosine theta equals to 7 over 9. Okay, cosine theta equals to 7 over 9. What is the meaning of the function that cosine theta equals to 7 over 9? We have here a right triangle with the hypotenuse that equals to 9 units and the side that is near angle theta is equal to 7 units. That is the actually the expression of this function cosine theta equals to 7 over 9. That is the way that we can draw this function. So the only missing side, that is the side that is in front of angle theta. And we can easily find out the size of the length of this side that is in front of angle theta according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say s squared plus 7 squared equals to 9 squared. So x squared plus, we subtracted, so s squared, 7 squared is 49, 9 squared is 81. So in conclusion, we found out that s squared plus 49 equals to 81. We subtracted 49 from this equality and we got that s squared equals to 81 minus 49 is 32. Then we took a root out of this equality and we got that s equals to the square root of 32. 32 is 16 times 2. And the square root of 14, the square root of 16 is 4. So in conclusion, we found out that s equals to 4 times square root of 2 units. So now we can easily also find out the value of sine theta. From this drawing, we can see that sine theta equals to 4 times square root of 2 over 9. Sine theta equals to 4 times square root of 2 over 9. Okay. So in conclusion, we found out that sine theta equals to 4 times square root of 2 over 9, and we already found out that cosine theta equals to 7 over 9. According to equation number 1, sine theta equals to x over 7. Sine theta equals to x over 7. According to this equation number 1, sine theta equals to x over 7. And now we know that sine theta equals to 4 times square root of 2 over 9, so we can substitute sine theta in equation number 1 by 4 times square root of 2 over 9. We did it and we got that 4 times square root of 2 over 9 equals to x over 7. We multiplied this equation number 1 by 7, and we got that x equals to 29 times square root of 2, x equals to 28 times square root of 2 over 9. Okay, so we can write here that x equals to 28 times square root of 2 over 9. Here also x equals to 28 times square root of 2 over 9. And AD equals to x plus x, that is to say AD equals to 2 times 28 is 56 times square root of 2 over 9. And AD equals to BC, because the opposite sides of a rectangle are equal to each other. So BC will be also equal to 56 times square root of 2 over 9. And we have already found out that cosine theta equals to 7 over 9, so we focused on the right triangle, triangle AEB. On this right triangle, triangle AEB, we know that cosine theta equals to AB over 7. Cosine theta equals to AB over 7. But we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta in this equality by 7 over 9. So we did it and we got that 7 over 9 equals to AB over 7. We multiplied this equation by 7 and we got that AB equals to 7 times 7 is 49 over 9. So we found out that AB equals to 49 over 9, and because of the fact that the opposite sides of a rectangle are equal to each other, that is to say AB equals to CD. And if AB equals to 49 over 9, then DC will be also equal to 49 over 9. Then we focused on the right triangle, triangle BFC. On this right triangle, triangle BFC, you can see that cosine 2 theta equals to FC over 9. Again, cosine 2 theta equals to FC over 9. Okay, in the right triangle, triangle BFC, cosine 2 theta equals to FC over 9. We multiplied this equation by 9 and we found out that FC equals to 9 times cosine 2 theta, and we have the trigonometric identity that cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine 2 theta in this equation by 2 times cosine square theta minus 1. So we did it and we got that FC equals to 9 times 2 times cosine square theta minus 1. But we know that cosine 2 theta equals to 7 over 9. So we can substitute cosine square theta in this equation by 7 over 9 square. So we did it and we got that FC equals to 9 times 2 and cosine square theta is 7 over 9 square minus 1. So FC equals to 9 times 7 over 9 square is 49 over 8, and minus 1 is minus 81 over 81. And in conclusion, we got that 9 times 2, 49 minus 81 over 81 equals to FC. So here 2 times 49 is 98. So in conclusion, we found out that FC equals to 9 times 98 minus 81 over 81. 98 minus 81 is 17. So we got that FC equals to 9 times 17 over 81. We divided the numerator and the denominator by 9. And 9 over 9 is 1. So in the numerator we left only with 17. And 81 over 9 is 9. So in the denominator we have only 9. So in conclusion, we found out that FC equals to 17 over 9. Then what is the value of DF? DF equals to DC minus FC. DF equals to DC minus FC, but DC equals to 49 over 9. We already found out that FC equals to 17 over 9. 49 minus 17 is 32. So in conclusion, we found out that df equals to 32 over 9. df equals to 32 over 9. Then we can easily find out the area of this green shape, that is also the area of trapeze ABDF, and the area of any trapeze equals to the sum of its sides. In this case it is AB plus DF times the height, that is AD over 2. And we have already found out that AB equals to 49 over 9, DF equals to 32 over 9, and AD, that is the height of the trapeze ABDF, equals to 56 times square root of 2 over 9. And here 49 plus 38 is 81. So we have here 81 over 9 times 9, over 9 times 9, 81 over 9 times 9 is 81, so 81 over 81 is 1, so 81, this expression will get cancelled, and we left only with 56 times square root of 2 over 2. 56 over 2 is 28, so we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, the area of the green shape equals to 39.6 square units. So we finished with the second method. Then I showed to you how to find out the area of this green shape according to a third method. In the third method, we actually made a construction. We made a construction from point E. We drew perpendicular to BF, and we defined the touching point between the perpendicular from E to BF as point M. So this angle equals to 90 degrees, and this angle equals to 90 degrees also. Then we proved that those two right triangles can go into each other. Okay, we proved that the right triangle AEB, is congruent to the right triangle EMB. Why they can go into each other? First of all, we know that those two angles, they are equal to each other. They are both equal to theta according to what is given us in the question. So angle AEB is equal to angle EMB, and both angles are equal to theta according to what is given us in the question. We also know that those two angles are right angles. They are both equal to 90 degrees. So angle BAE equals to angle EMB equals to 90 degrees. And those two angles, they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle can go into two angles in another triangle, then the third pair of angles must also congruent. And we proved that we proved that those two angles in triangle BAE congruent to those two angles in triangle BME. Therefore, the third pair of angles, those two angles must be equal to each other. So those two angles are equal to each other according to third angle theorem. That is to say, angle BAEB is equal to angle BEM according to third angle theorem. And we also know that BE is equal to BE. It is a common side that belongs to both triangles. So we actually proved that triangle AEB is congruent to triangle EBM according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that AB equals to BM, AB equals to BM, and if we define AB as Y, then BM will be also equals to Y. So AB equals to BM equals to Y, and also AE is equal to EM. From the fact that those two triangles can go into each other, we will conclude that AE equals to EM, and if AE equals to X, then EM equals to X. So AE equals to EM equals to X. And because of the fact that AE equals to ED, then if AE equals to X, then ED will be also equal to X. Okay? And here also, because of the fact that BM equals to Y and BF equals to 9 units, then MF will be equal to BF, that is 9 units, minus BM, that is Y. So MF will be equal to 9 minus Y. Then we proved, we actually connected together points E and F by a straight line, and we proved that those two right triangles can go into each other. Why they can go into each other? Because of the fact that EM equals to ED equals to X, EM equals to X, ED also equals to X, so they are equal to each other. They are both equal to X. And those two angles, they are both right angles, therefore they are equal to each other. So angle EMF equals to angle EDF equals to 90 degrees, and EF equals to EF. It is a common side that belongs to both triangles. So by proving those three things, we actually proved that those two right triangles can go into each other according to rule number 5. And what is rule number 5? Rule number 5 says that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And we actually proved that the hypotenuse EF and the perpendicular EM in the right triangle EMF is congruent to the hypotenuse EF and the perpendicular ED in the right triangle EDF. Therefore, we proved that those two right triangles can go into each other according to rule number 5. Okay, we proved the triangle EDF is congruent to triangle EMF according to rule number 5. And from the fact that those two triangles can go into each other, we will conclude that MF equals to DF. We will conclude that MF equals to DF. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding side MF and DF will be also equal to each other. And if MF is 9 minus Y, then DF will be also equal to 9 minus Y because of the fact that they are equal to each other. From this equality, we will get that DF also equals to 9 minus Y. Okay? So DF equals to 9 minus Y. And we know that AB equals to DC, so if AB is Y, then DC will be also Y. And what is the value, actually the value of FC? The value of FC is equal to DC minus DF. Okay, the value of FC is equal to DC minus DF. DC equals to Y. DF is equal to 9 minus Y. So FC equals to Y minus 9 minus Y. We open the brackets and we got that FC equals to Y minus 9 minus Y. Minus Y is plus Y. So in conclusion, we got that FC equals to Y plus Y, 2Y minus 9. FC equals to 2Y minus 9. Here FC equals to 2Y minus 9. And AD is equal to BC according to the rule that the opposite sides of a rectangle are equal to each other, and A equals to X plus X, AE equals to 2X, then BC will be also equal to 2X. And in the right triangle, triangle ABE, according to the Pythagoras theorem, X squared plus Y squared equals to 7 squared, that is to say, X squared plus Y squared equals to 49. And in the right triangle, triangle BFC, this right triangle, according to the Pythagoras theorem, the square of the hypotenuse is 9, so the square of the hypotenuse is 9 squared. 9 squared is 81. It equals to the sum of the squares of the perpendiculars. That is to say, it equals to FC squared plus BC squared. So we got that 81 equals to FC squared plus BC squared. FC equals to 2y minus 9, so FC squared will be equal to 2y minus 9 squared. plus BC squared. BC is 2x, so BC squared will be equal to 2x squared. We open the brackets of this equation in this side of the equation number 2, and we got that 81 equals to 2y minus 9 squared. 2y minus 9 squared equals to 4y squared plus 81 minus 36y, and 2x squared is 4x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled, and we left only here in this side of equation number 2 with 0. Here we took a common factor of 4 from 4xy and 4xy and 4 times y squared, 4 times x squared and 4 times y squared. We took a common factor of 4. So inside the brackets we have x squared plus y squared minus 36y. And according to equation number 1, x squared plus y squared equals to 49. So we can substitute x squared plus y squared in equation number 2 by 49. We did it, and we got that here 36y equals to 4 times x squared plus y squared. So we substituted x squared plus y squared by 49, and we got that 36y equals to 4 times 49. We divided this equation by 4, and we got that 9y equals to 49. We divided this equation number 2 by 9, and we got that y equals to 49 over 9. Okay, y equals to 49 over 9. And y equals to 49 over 9. But according to equation number 1, x squared plus y squared equals to 41. So we can substitute y squared in equation number 1 by 49. We can substitute y squared in equation number 1 by 49 over 9 squared from equation number 2. We did it, and we got that x squared plus 49 over 9 squared equals to 49. Then we subtracted 49 over 9 squared from this equation number 1. And we know that 49 is 7 squared, so in conclusion we got that x squared equals to 7 squared minus 49 over 9 squared. And then we have the trigonometric identity, the algebraic identity, that a squared minus b squared equals to a plus b minus times a minus b. Here b squared is 0, a equals to 7, and b equals to 49 over 9. So according to this algebraic identity, we get that x squared equals to a plus b. A plus b is 7 plus 49 over 9, and a minus b is 7 minus 49 over 9. We multiplied 7 by 9, and then we divided by 9 in order to have a common factor of 49 over 9, and we got that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. 63 plus 49 is 112, and 63 minus 49 is 14. So in conclusion, we got that x squared equals to 112 over 9 times 14 over 9. We know that 112 is 8 times 14, so we substituted 112 by 8 times 14, and we got that x squared equals to 8 times 14 times 14 over 9 times 9. And then we also know that 8 equals to 2 times 2 times 2, so we substituted 8 by 2 times 2 times 2, and we got that x squared equals to 2 times 2 times 2 times 14 times 14 over 9 times 9. We took a root out of this equation number 1, and we got that x equals to this expression, and the square root of 2 times 2 is 2, and the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. So in conclusion, we got that x equals to 2 times 14 over 9, and inside the root only we have 2, so it is square 2. X equals to 2 times 14 times square root of 2 over 9. 2 times 14 is 28, so in conclusion we got that x equals to 28 times square root of 2 over 9, and we already found out that y equals to 49 over 9. Then we know that the area of any trapeze, that is also the area of the green shape of the area of trapeze ABDF, equals to the sum of its sides times the height over 2. The sides is AB plus DF, so the sum of its sides is AB plus DF times the height, that is AD over 2. We know that AB equals to Y. DF equals to 9 minus y, and AD equals to 2x, all divided by 2. Y plus 9 minus y, so y minus y is 0, so we're left only with 9, and 2 over 2 is 1, so here, in this side of the equation, we have only 9x. So the trapeze ABDF equals to 9x. And we have already found out that x equals to 28 times square root of 2 over 9. So 9 over 9 is 1, so we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, thank you very much.